All right, next section, foiling. You have to find the product. Product means multiply. You're going to FOIL for number 205 and 206. You have polynomials. For number 207 and 208, you have trinomials. So make sure that you are going to distribute the negative 8k to every single one. And then you're going to distribute the 5k to every single one. And then finally, you're going to distribute the negative 8 to every single one. Okay, and then from there you can get the answer. So I'll do that. That one's a very long problem, but I will do it. Let me just make this a little bit bigger on the left side. So negative 8k squared times negative 6k squared is 48k to the fourth. And that times 6 is negative 48k third plus 8k squared. And then in my blue, 5k, so you get negative 30k squared plus, k cubed plus 30k squared minus 5k minus 5k. And my last one, negative 8 times 6 is 48k squared minus 48k plus 8. Okay, so negative 48k cubed, negative 30k cubed, I can combine those. So I get negative 78k cubed. I get 48k to the fourth. That's done. This is done. So now I have this k squared and those. So that would be 56 plus 30. So 86k squared. I'm going to underline the negative 5, underline the negative 48. So I get negative 53k plus 8. And this would be my answer. Okay, so I think you are now able to do the rest of those problems. I'm going to go now onto the next section where it says factor the common factor out of each expression. And in this section right here, you're really only taking out the biggest factor or the largest common factor out of this expression. So I'm going to do a few. I'm going to start with 216. So I know that there is a 2 in common because they're all even. And I'm going to try something bigger than 2. So let's try and see if, I think the biggest number I can pull out from there is an 8. So I'm going to take out a negative 8. And then I notice that there's an x squared, an x, and an x here. So the biggest x value that I can factor out of these expressions, or these terms, is 1x. So now I'm going to continue. And so since I factored a negative 8, x, I can parentheses and say, okay, negative 8 times something equals 32, so 4xy squared plus, minus 7y squared minus 6, and this would be my answer. Okay, let's try one more. I'm going to try to do 217. So I'm going to check with my calculator if 72 is divisible by 9. Yep, and 81 is also divisible by 9. So let's start there. Let's start with a 9. So I'm going to pull out a 9. I'm going to pull out 1x because I have an x squared, and just 1. So the biggest x I can pull from all three is 1. And then same reason from the last problem. I have a y squared, a y, but I don't have anything here, so I cannot pull that out. So open parentheses, and I get 8xy squared minus 9x xy plus 3. And this would be my answer. All right, now we get into the tricky part of factoring. We're going to factor each completely, and I'm going to teach you the cutesy way. I know I promised you 2 different ways. I may or may not do one right now. I really want you to get into the habit of doing the what I call the cutesy method. And so the first thing you're going to do, and let's say we're looking at number 219, we're going to look at our first and our third term. And we're going to look at factors of our first term. So I know that there's an invisible 1 in front of the r squared, and I know that 1 times 1 is 1. And those are the only factors that actually multiply to 1. Now 10, I have a few options. I have 2 options. I have 2 and 5 that multiply to 10, or I have 10 and 1. And so now what we want to do is actually find a combination that's going to give us this negative 11 in the middle. So I'm going to start off with 1 and 1 and 2 and 5. And I'm going to cross multiply. 1 times 2 is 2. 1 times 5 is 5. And my question is, will the combination of these two, when I add them or subtract them, will it give me negative 11? And the answer is no. So this combo will not work. So I'm going to try 10 and 1. So 1 and 1 and 10 and 1. And I'm going to cross multiply the same way. So I get 10. And I'm going to cross multiply the same way and I get 1. Will the combo of these two numbers actually give me the negative 11? And the answer is yes. But I'm going to have to make sure that they're both negative. And so I want to make sure that you know not to touch this first column here. And you can always change the second column's signs. So I'm going to make a green sign here so I know that this is a negative and this is a negative, so that 1 times negative 10 would give me the negative 10, and 1 times negative 1 would also give me the negative 1. So now that I know this, I can go ahead and draw my 2 factors. So I'm going to have x minus 10 and x minus 1. And this would be my answer for number 219. Okay, so now let's do number 220 the same way so that you kind of get into the habit. So 2 factors of 1, the invisible 1 that is here, is 1 and 1. 2 factors of 48 is 6 and 8. What else? 48 divided by 12 is 4, so I could get 12 and 4. And somehow I want to get this negative 14 in the middle. So I'm going to test these out, and I'm going to say 1 and 1, and let's say 6 and 8. If I cross multiply, I get 6. If I cross multiply, I get 8. And yes, the combo will give me 14, but I want to make sure that they are negative. So how would I get a negative? Well, if I change this to a negative, I change my number in the second column as a negative, now I can actually draw or write out my 2 factors, or my polynomial, 1x minus 6 and x minus 8, and this would be my answer for number 220. So now let's try one where the first term is not a 1. So let's, for example, start off with 225. And I want to start off with 225 because I notice that my terms are all divisible by at least 2 because they're all even. So before I start factoring any trinomial, I always want to factor out whatever I can. So I know there's a 2, so my 2 can come out. I get 15n squared minus 63n plus 12. And from here, I can go ahead and do the cutesy method. And I'm going to move my iPad so that you can see it on the left side and I can work there a little bit neater. So again, I'm going to ignore the 2, and I'm going to write down my trinomial, 15n squared minus 63n plus 12. And I'm going to write down my factors of 15, which is 3 and 5, and 15 and 1. And then my factors of 12 are 6 and 2. Well, actually, before I do this, I can actually divide by 3 again. Can I divide by 3? I can, in fact, take out a 3. So let's take out a 3. So if I take out a 3, I get 5n squared minus 21n plus 4. And now I'm going to include this 2 because we've already factored that out. So really my problem should look like this, because I was able to take out a 6 completely. Okay, so now it's a trinomial that I can actually factor, and it's simplified. So 2 numbers that multiply to 5 are 5 and 1, and 2 numbers that multiply to 4 are 2 and 2 or 4 and 1. So let's start trying to make those combinations. So I'm going to start off with 5 and 1, and then I'm going to do 2 and 2. So if I cross multiply, I get a 2. If I cross multiply, I get 10. This combo will not give me the negative 21 that I'm looking for, so that's not a good combination. But let's try 4 and 1. So 5 and 1, and I could do 4 over 1, but when I multiply, this would be 4 and this would be 5, and that's not what I want. So what I want to do is I want to switch the order. So let's say I switch the order, and I say 5 and 1, and 4 on the bottom and 1 on top. So when I cross multiply, I get 1, and I cross multiply, I get 20. And so this will give me the 21 that I'm looking for. But the only thing, I want them to be both negative. So I want this to be negative, I want this to be negative. Make sure you are not touching the first column. So don't touch the 5 or the 1, but I do want to make the negative 1 and the 4 a negative. So now that I have that, this is going to be 1 parentheses, and this will be my second parentheses. So I can write down 5 n minus 1, and then n minus 4. And so these 2 are going to be added to the 6 I originally had over here. So ultimately, my answer should look like this. 6 parentheses 5n minus 1 parentheses n minus 4, and you have now factored the trinomial completely. Okay, so let's go on and do one more. We'll do 226. 226 is right here. So I'm going to do the same thing. I don't think that 3, 29, and 40 have anything in common. So I'm going to go ahead and start doing my cutesy method. 2 numbers that multiply to 3 are 1 and 3. And 2 numbers that multiply to 40, well, I can do 2 and 20, or I can do 4 and 10, or I can do, let's see, 40 divided by 12, no, 40 divided by 5 is 8 and 5. So I believe those are the only 3 combos. Okay, so now that I've had a little bit of practice, I can see that 1 and 3 is going to be a good combo, not necessarily with 2 and 20. And I want to say 4 and 10 won't work either. But maybe 8 and 5. So let's try 8 and 5. So 8 times 3 is actually 24. And 1 times 5 is 5. So yes, that gives me the 29 that I am looking for. Everything is positive, so I can just draw my arrows and my parentheses, so x plus 8 and 3x plus 5, and this will be your answer for number 226. And I want you to pay attention to numbers 229 and 228, because these are called perfect binomials. So I have two perfect, it's the difference of perfect squares. So the rule is that whenever you have difference of squares, it's always going to be x plus 2 and x minus something. So not 2, but it would be x plus y and x minus y. And the reason I have a plus and a minus is because I don't have a middle term. So if you notice on 230, there is a middle term. If you notice on 229, there is no middle term. If you notice on 227, then there is a middle term. If I don't want a middle term, then of course a plus and a minus is needed because I don't want that middle term to be there. And because they are perfect, then I can very easily just say x plus 2 and x minus 2 because 4 is a perfect square. Okay, and if I were to do 229, I know 16 is a perfect square and 25 is a perfect square, and so 4n plus 5 and 4n minus 5 would be my answer for number 229, whereas this is my answer, x plus 2 times x minus 2 for 228. So if, for example, let me just go somewhere randomly. If I had like 81x4 minus 49y6, then my factoring would go something like this: 9x squared plus 9x squared minus, would be 7y to the third and 7y to the third. And this would be my answer for that example. So hopefully factoring is a little bit easier for you now that you've seen this video, you've practiced some problems, you've checked with someone. Let's continue to factor by grouping. So the next section, you are factoring by grouping, and usually it's the first two and the last two terms. I did give that hint in your worksheet as well. So let's start with 232, and so I'm gonna underline in two different colors. And so in this case, I can pull out an x squared, and then this would be x plus 2, plus I can pull out a 3, and I have x plus 2. Oh my goodness, this x plus 2 and this x plus 2 look the same. So now what I can do is x plus 2 times these two terms, which would be x squared plus 3, and this is now my answer. So let's try one more. Let's try 235. So I have these two terms, and I have these two terms. So I'm going to have a 2. I can pull out a 2, and I can pull out an a. This would be 2b minus 3. And in orange, I can pull out a 7, and I would have 2b minus 3. Look at that. I have a 2b minus 3 and a 2b minus 3. So I'm going to write 2b minus 3 in parentheses, and then my next parentheses would be my 2a and my positive 7. So 2a plus 7, and this would be my answer. Okay, why not? Let's just do one more. So 236. Let's do these two terms and these two terms. So the first one, I could pull out a 3 and an x, and I could do a 5y plus a 4. And then my other one, I'm going to pull out a 8y cubed, and I can make this a 5y plus a 4. And I'm making it easy so that you can see. Okay, so I do have the same terms, so 5y plus 4 would be my first, and then my second would be 3x plus 8y cubed, and this would now be my answer. Yay, we've gotten down to solving each equation by taking the square roots. So I'm going to zoom in right here. So solve each equation by taking the square root. So really what you're doing is just solving. And they're telling you to by taking the square root because, well, you're going to have a square root in here. So again, reminder that the opposite of adding is subtracting. The opposite of multiplying is dividing. The opposite of squaring something is square rooting. Okay, so let me zoom in a little bit more, and I'll do a few of these problems. So let's start with 238. Whoops, let's start with 238. And so the first thing to isolate the variable, I'm going to divide by a -3. So divide by -3, divide by -3. So v squared equals -4. Okay, and if I take the square root and I take the square root of a negative number does not exist. You'll learn about imaginary numbers, which do have a negative underneath the square root. But for now, since that is a rule that you have not learned yet, this problem is no solution. Okay, so let's do one that actually has a solution. So let's do 240. So I'm going to add 1 to both sides. And I get x squared equals 49, and the square root of this and the square root of that. So x equals plus or minus 7, and that is my answer. Let's do one more. So I'm going to add 3, n squared equals 4, so x equals plus or minus 2. And let's do one that's a little bit more complicated, maybe like 243. So I'm going to divide by 81 and divide by 81, divide by 81. So x squared equals 25 over 81. And I don't want to change that into a decimal because 25 is a perfect square and so is 81. So when I square root this, I actually can say the square root of 25 and the square root of 81. So I know the square root of 25 is 5, the square root of 81 is 9. So my answer is x equals 5 over 9 plus or minus. Okay, and we'll do one more. Who knows how many people are actually listening to all of this, but the video is 2 hours long so far, I believe. Maybe not. I don't know. Okay, so 246. I'm going to subtract 14 from both sides. So I have my handy calculator. 375 minus 14 equals 361. 49x squared. So 361 divided by 49 is actually not a pretty number. But let's see if 361 has a square root, which I don't believe it does. Oh, it does. Okay, so I'm going to do the square root of 361 and the square root of 49. So x equals plus or minus 19 over 49. And this would be my answer. Okay, so the next section is actually very simple because, again, you're still doing the inverse operations for all of these. Now, in this section, solve each equation by factoring. Okay, well, it's already factored, or the first 3 are actually factored, right? 247 is already factored, 249 and 248 are already factored. So what you really want to know is understand that these two terms are being multiplied. So x and x minus 2 are being multiplied, and it's going to equal 0. So something times something equals 0. Well, one of those answers is going to have to equal 0. So either x equals 0 or x minus 2 equals 0. So x equals 0 is one answer because I'm done. And then the other one, I'm just going to isolate x, so x equals 2. So really my answer is x equals 0 or x equals 2. And this would be where I'm done. Now if I do 248, same thing, right? Either v minus 2 equals 0 or v minus 5 equals 0. So v minus 2 equals 0. or v minus 5 equals 0, and add 2, so v equals 2, or add 5 and add 5, so v equals 5. And those would be my two answers. And don't be scared like 249 where you get decimals, not decimals, fractions. So again, your first polynomial or your second polynomial is going to equal 0. So n minus 2 equals 0, or 2n plus 5 equals 0. And you're going to solve, so subtract 5 from both sides. You get 2n equals negative 5, divide by 2, divide by 2. So n equals negative 5 over 2 as one answer, or plus 2 over here, and n equals 2. So these would be my two answers there. Now what happens when it does not equal 0? Well, let's try one that has a little bit more room. So I'm going to go over here because I have two problems. So let's do 250 and 252. So it doesn't equal 0 yet, but I can make it equal to 0. So I'm going to bring my negative 56 to the other side. So really I have x squared plus 15x plus 56, because I brought it over, equals 0. So now I can factor, and you'd have to do the cutesy method or the diamond method. So here's x, here's x. So I need two numbers that multiply. So I'm going to do it in orange. So I have 1 and 1, and then two numbers that multiply to 56. So 56 divided by 8 is 7, and I believe 8 and 7 actually gives me that middle term of 15. So 8 and 7, everything's positive, so I'm going to have plus 8 plus 7. But I'm not done. So now I know that this term, or this polynomial, equals 0, or this term, and we go back to what we were doing originally. So x plus 8 equals 0, or x plus 7 equals 0, so x equals negative 8, and x equals negative 7. And those are my two answers for number 250. Now for 252, let's do purple. Okay, so 252, again, it does not equal 0 yet, so I'm going to have 8a squared plus 80 minus 56a equals 0. And if you notice, they're kind of out of order. The exponents should always go in decreasing order, so from largest to smallest. So I'm going to rearrange this and say 8a squared minus 56a plus 80 equals 0. And I can tell that they're all divisible by 8. So I'm going to take out an 8 to make my life easier. And a plus 10 equals 0. So now I have a, and I can factor. And two numbers that multiply to 10, or to 1, right, because this is a 1. So 1 and 1, and two numbers that multiply to 10 is 5 and 2, and I want it to add up to negative 7. So these two numbers add up, multiply to 5, these two numbers multiply to 2, they both have to be negative, so I'm going to make this a negative 5 and a negative 2, because negative and a negative, so x minus 5 and x minus 2, and that's what I did. Or not x, I should have said a in this case. So now I look at a minus 5 and a minus 2, so a can either equal 5 or a can equal 2, and this would be my answer. Okay, great. Next section. Square roots. We know couples go out, loners stay in. So let's just kind of zoom in right here, and I'm going to say couples go out, loners stay in. Okay, so if we take a look at 254, 256, you could always use a calculator. Those are easy. But let's take a look at 258. Okay, so 258, I have 2 square root of 30r. Okay, so I'm going to break this down, and I get 2 and 15. I get 3, and 5. And that's it. And then my r is just here. So there's no couples. So this is actually already simplified. So what we would write is the actual number that they gave us. So 2 square root 30r, and I'm done. Now for 260, there are couples. So let's try to bring this over here. So 6 square root of 400p. So if I break this down, I get 4 and 100. I break this down, I get 10 and 10. Break this down, I get 2 and 2. There's a couple here and there's a couple here. So one comes out and another comes out. So essentially, I have my 6, which was on the outside, times 1, 2 times 110, square root. Who's my loner? This p. Why? Because he does not have a couple. So p would go in here. 6 times 2 is 12 times 10. So my answer is 120 square root of p. And this would be my answer for number 260. So I'll put that in over here. So 120 square root of p is my answer. Okay, moving on to the next section. It's the same thing, however, you have variables. So I'm going to do just 2 problems here. So I'll do, let's see, I'll do 262 and 264. So I'm going to break this down. So 128 divided by 2 is 64. Divided by 8 and 8. So here's my couple. I have a loner here. Now a could be a squared times a. Then I have b, which is a loner. And then c would be c and c. So I'm going to couple, and I'm going to couple, because that's 2, right? Because if I break this down, it would be a and a. So here's a couple. So out of this couple, 1 comes out. Out of this couple, 1 comes out. Out of this couple, 1 comes out. So let me underline or box or in red. Here's a loner. Here's a loner. And here's my loner. So ultimately my answer is 8ac square root of 2ab. And that is my answer. Moving on to 264. So 264, I'm going to break this down. So I know it's 100 times 10, and I know 100 is 10 times 10. And so I know my x cubed is going to be x times x times x, my y times y, and my z times z. So I'm going to couple what I have. Okay, and I'm going to underline my loners. Okay, so out of this couple, 1 comes out, 1 comes out, 1 comes out, 1 comes out. So I have the -3 times the 10, which is -30. And then I have x, y, z, square root of my loners. My loners were 10, x, and y. And this would be my answer. Okay, so hopefully now you know how to simplify. And I want you to make sure you understand that at the very top it said use absolute value signs when necessary. And so the idea is if you take a look at 262, even though that's my answer, I should be putting absolute value signs here and here. Why? Because, well, we need to make sure that whatever's underneath our square root is positive numbers. So if it's by itself, we got to make sure that they are, oops, let me make this a little bit bigger. So my absolute value here, and then I would have an absolute value there and there. Okay, so now you get the idea. Moving on, almost done. All right, So if I move on to the next section, I'm simplifying with square roots. Now the square roots, I want you to make sure you treat them like variables. So if they are the same, you can actually add them. So for example, if I looked at 266, I have a 4 with the square root of 8 and minus 4 square root of 8. They are the same. So that's really like saying 4x minus 4x, which is in fact 0. And if we do 268, it'd be the same thing. So I have square root of 7 and square root of 7. So it's kind of like saying negative x minus 5x, which is negative 4x. So my answer is going to be negative 4 square root of 7. So treat your square roots as a variable. But people have difficulty with problems like 270 because, oh my gosh, the square roots are not the same. So what we want to do is make sure that they are the same. So I'm going to break this down, and I get 4 and 3, and this is 2 and 2. And so I have my group, my couple, so that goes out. So here I have negative 4 square root of my loner. And then plus, I'm going to break this down, so I get 9 and 6, and this would be 3 and 3. So here's my group that comes out. So I get 9 square root of 6, and then minus, I can't do anything to the last one, so there's that. Now, I can't combine them all, but I can combine the first and the last one. So negative 4 square root of 3 minus square root of 3 would actually give me negative 5 square root of 3 plus 9 square root of 6. And this is now my answer.